Hi everyone. I hope your week is going well. In this video, we are going to start talking about functions. Okay, so a function you can sort of think of as a map from one set to another set. Okay, so we have one set of numbers here. We'll call this set A, and we'll call this set B. And a function maps from A to B. And usually we denote a function with some kind of letter. Okay, and we have inputs for this function that come from some set and go to another set. Okay, so one thing that we have to note about a function, though, is that each input for a function can only have one output. Okay, so for example, if we have a function f that sends 1 to 2, um, then if f of 1 also goes to 4, this is not a function. Okay, so we can't have this, right? We can't have the same input going to two places. Okay, so let's look at a few different maps, a few different functions, a few different examples of maps, and see if they actually qualify as a function. Let me go back up here real quick. Though one other thing I wanted to mention before we move on is that the place that we're pulling values from is the domain, and the place that the function maps onto is what we call the range. So we think of the domain as kind of the inputs for the function, and the range is the outputs of the function. That will be important. Okay, so now as we look at these maps, let's take a look at the domain and the range and see if this actually qualifies as a function. Okay, so here we have A being mapped to 0, B is being mapped to 1, C is being mapped to 2, D is being mapped to 3, and E is being mapped to 4. So each of these have one output. Okay, so this is going to qualify as a function. Okay, how about this one? Here we have A, B, C, D, and E all being mapped to the number 1. Is this a function? Well, they're all being mapped to one number, but it is important to know that they're like each input only has one output. So this actually still is a function. Okay? So the fact that all of them are going to 1 is not an issue at all. Okay? Now let's look at this one. Here we have A being mapped to 0 and to 1. B goes to 1, C goes to 1, D goes to 1 and 3, and then E goes to 4. So this is not going to be a function. And the reason that this is not going to be a function is here we have A gets mapped to 0 and to 1, and D gets mapped to 1 and to 3. Okay, so this has two outputs for a multiple, really for any element in the domain. So therefore, we cannot call it a function. Okay, and this gives rise to something a little more applicable for what we're often going to be doing with graphing. This is the vertical line test. Okay, so if you want to check whether or not something is a function just by looking at its graph, a really good way to do that is to use the vertical line test. Okay, so let's take a look at this first one here. Here we have some kind of absolute value type function here. And so what we're checking for here with the vertical line test is we're seeing if there's any point where we can draw a vertical line and cross more than one point of the function, okay, or of the map, okay. If we're able to cross more than one point using a vertical line, then it is not a function. But this one actually passes it because it does not cross more than one point. So we would say that this one is a function. Let's look at this circle though. So let's draw a vertical line. If we draw a vertical line right down the middle here, what we'll notice is that this value here on the x-axis is being sent both to here and to here. Okay, so that means it has two outputs. That is the logic behind the vertical line test. If you can draw a line and cross a vertical line and cross more than one point, that means one input has more than one output. Okay, so therefore this is not a function. Okay. How about this curve here? Well, if we draw this vertical line, we're going to see that it crosses 2 points. So this point here is being sent both here and to here. Therefore, this is not a function. Okay, let's look at some trickier examples. These are what you call step functions. These are functions that they're not necessarily continuous. So they go at one value and then they drop or raise in value suddenly. Okay, so here we have this function here it's starting here from the left and it's going forward this way, and then we don't include this point here, and then at that point it drops here and continues forward, okay? So let's see if this is a function. Well, obviously it's fine along all of these points, right? This is fine, and it's fine over here as well. So the one point we're looking at that's suspect is really this point here, okay? However, we don't include this point, but we do include it here. So we really aren't having any major issues with the vertical line test for this graph. Okay, how about this one? Here we have uh, uh, a map here. It looks like another step map of some sort here, but it's not going to be a function. So if we draw a vertical line along the y-axis here, we'll notice that we hit both this point and this point, so it would not be a function. Okay? And then lastly, let's look at this one. Here we have another step function, or map. I shouldn't call it a function until I know it's a function. But if we draw vertical lines here, we'll notice that we are fine, right? These are not exactly vertical. I didn't draw the best graph, but you get the idea, right? These are fine. Since we're only crossing one point at a time here, because of these open dots, we are fine. If these had been closed circles here, we would not be fine. So that's something to note. Okay.